All right, so I started talking on a previous video and just kind of updated what we're going to be doing and how grading will go. So a quick review, anything that I'm doing now is just in addition. It is not required. And anything that was required will be due by June 9th. So even if something in our online no reassignment has expired, you are still able to continue to work on those by just unlocking them with the coins that you have earned. Complete it, take a screenshot of your achievement board and email that to me, and I will update the grades. So everything that you still have that's outstanding, that needs to get to the grade book, you can continue to send me. You can continue to ask questions about. You can meet me during either our Zoom sessions, our live streams like this, or if you want something more individualized, we can work out a time that you and or maybe a few people want to join to specifically go over something. With that being said, what we're going to do in addition is kind of add here or there. We're going to add some information like circles that are going to be a necessity for next year and for all of the standardized tests that some of you will be taking, whether it be for ACTs, SATs, AccuPlacer, even job placement. I know I years ago had to take a math test to work at Dillard's of all places. So it will cross over and it will be a benefit. So that's what we're going to do today. In order to get accustomed to circles, I want to talk about some basic vocabulary that I truly believe many of us still need to talk about. The first thing that I do want to make mention of is that a circle is kind of like a rubber band. There is no it doesn't fill in. So kind of like my rubber band, we can be on the circle, we can be in the circle, and we can be outside of the circle. But our circle isn't a disc. It's not filled in like the top of a tin can. So when we look at our circle, the first thing that we need to keep in mind is that the center of a circle is always designated with a capital letter. So we'll go ahead and call this circle A. The symbol is a circle with a center dot. You can kind of see that. And we put our capital letter next to it. So again, that's going to translate into circle A. So when we see our symbol, that's what we would say. Because we now know that there is a center, now we can specifically talk about some other segments. The first segment that we want to talk about is a diameter. Now, I know that you know, but we're going to repeat that a diameter has to specifically go through the center, and the end points fall on the circle. So notice again, kind of like our rubber band, those end points, oh look at that, that's almost exact. The end points fall on the circle, and this segment reaches across. And so what we end up with is our segment BC is considered a diameter. So BC is a diameter. It is specifically going to go through the center, and both endpoints are on the circle. Now, I know that's something that we've talked about, but I want to make sure that we are aware of that. Now, when we talk about another segment that has to deal with our circle, we do have another one like this, where we could talk about AD is a radius, so is AB and AC. Notice how every one of their endpoints is the center of our circle. And that has one endpoint at the center, and the other end point on the circle. Now, don't forget that the radius is half our diameter. So whatever our diameter is, we could split it in half, and no matter how many radii, plural radii, you end up with the same measure all the way around. So if our diameter was 10, we'd have our radius is 5, 5, and 5, and everywhere else where we could draw a radius is going to end up being 5. Now, the last thing that I want to introduce today with our segments is what's called a chord. Now, a chord kind of looks like our diameter. The only difference is that it doesn't go through the center. So our next one that we want to look at, EF, that is a chord. And again, both endpoints fall on the circle. So we have all segments. And each one of these we were already aware of, but this guy right here, notice it's C-H-O-R-D. It is not called chord. It is chord. It's a hard C, chord. And I want to point out that a diameter can be a chord. It fits that definition perfectly, endpoints on the circle. A chord cannot be a diameter necessarily because we don't know that it goes through the center. So a diameter is a chord because it does have endpoints on the circle. It just more specifically goes through the center. A chord does not necessarily have to be a diameter because it doesn't always go through the center. So that's something to kind of keep in mind when you're looking at some of these crossovers. So a couple things that we are going to then talk about with these segments to kind of finish off today's lesson is how our diameter and radius affect chords if they would ever intersect. So you can kind of see I drew my radius in this direction, my diameter in this one, and then I put the chord out of here so we could see them pretty clearly. And I am going to label these very quickly just so you have them. My diameter goes all the way across. The radius is just half of that. And then our chord, again, very much like a diameter, but does not go through the center. So let's talk about a circle. We have our center of our circle. We'll go ahead, it's kind of off center. We'll make it a little bigger, fix that. Have the center of our circle at X. So now what I'm going to do is I'm going to write up some things more geometry-like. I'm not just going to tell you. I am going to give us a given statement so that we follow the directions. We have circle X. We are going to call this guy AB. And we're going to call that C. And what I've done is I'm going to tell you that XC is perpendicular to AB. So I have these directions here in our given statement. And what I want to do is I want to talk about what's happening here. So the first thing that I want to talk about is this idea of perpendicular. And we have to remember one of the things that we talked about numerous times, and hopefully right now there are a few of you if you're watching and if you're listening, You can picture me right now standing at the front of the room, and I'm going to talk about how quickly I can get to the wall by the hallway. And we talked about where I was standing is the fastest path going to be me walking to my classroom door. Is the fastest path going to be me walking halfway up the wall? Or is the fastest path going to be me walking directly to the wall on the same line that I'm standing? And hopefully you can remember that I've talked about that. And at this point, you are now remembering that that perpendicular means fastest path. So when we talked about shortest distance from a point to a line, we always talked about that perpendicular. So when we have, our shortest distance and I understand that this is a line segment, but it has the same properties that we'll need for this. So right now what we know is this is our shortest path because it's perpendicular. What we're also able then to talk about is obviously if this guy is from the center, if I extended it, it would become a radius. So what we're going to look at is then if we just take this same thing and extend it, I'm going to try to find there we are, making a lot of noise, sorry. If I extend that, I can now have XD is a radius, and if a radius is perpendicular to a chord, which our chord is AB, it will bisect the chord. So we made it go through, but even if it didn't, it's going to automatically bisect that chord. So right away, because of this perpendicular, it not only is perpendicular, it's a perpendicular bisector. So it will automatically bisect that chord. And hopefully you can kind of see this right here. We have this if, our comma, kind of like our then, it will bisect the chord. We have a conditional statement. And if I have a conditional statement, we can also do the converse. So what we're going to do is we're going to flip this over and we're going to now talk about what's the converse of this. Pink paper. So now if I take a chord and I have a center, we'll call this center Z, X, Y, W. I'm not even going to put a letter here, but I'm going to tell you if if a segment is a perpendicular bisector of a chord, that segment will pass through the center of the circle. So that's the technical if-then statement, but if it passes through the center of a circle, that's where we have that radius diameter occurrence. So if our given statement said that we have a perpendicular bisector, then what I can conclude here, ZW is our radius. And if ZW is our radius, I have radii that would come off everywhere that I have Z. Now the last thing that I'm going to add to this is we see these right angles everywhere. And if I have these right angles everywhere, please don't forget right angles always remind us of our Pythagorean theorem. So here's one. Could be, now that we've done it, special rights. 30, 60, 90, 45, 45, 90 could also now imply trig. But the fact that we have our right angles, any of that can come into play now. So we're going to finish up with one example. I'm going to try to draw our picture a little bit more to scale than I have thus far. We're going to put our center. Now that looks pretty solid. I'm going to draw a chord. I'm going to draw that with our right angle. All right, and I'm going to give you the direction. So our given statement is going to specifically say circle X. So now I know that regardless of if I mention it or not, anything that goes through X is most likely going to be a radius or a diameter. So you can see right now, because I said circle X, XY is going to be a radius. I'm going to tell you that AB has a length of 16. I'm going to tell you that XW has a length of 6. And the question that I'm going to ask you is I'd like you to find the length of WY. So that's just this little guy here. Something under my paper. All right. So we've got a lot of information. And instead of worrying about what do, let's just worry about plugging things in. So if I have circle X, the first thing I know is that XY is a radius. Has an endpoint at the center, endpoint on the circle, so it's a radius. The other thing I notice is that XY is perpendicular to AB. That's a good thing, because what that means then is that XY is going to bisect AB, because we have that rule that says if a radius is perpendicular to a chord, it's going to bisect that chord. So right away, I'm going to put those tick marks in, and I'm going to label this side 8 and this side 8, because it said AB was 16. XW, we said, was 6. And so now we've got all this information, and we're trying to figure out, well, how do I get that piece there? Well, we've got a lot of options. One of the options is to remember that I do have a right angle, and that means I could have the Pythagorean theorem, I might have angle measures for special rights, I might have angle measures for trig. But what I do know for a fact is that XA is a radius. XB is a radius. XY is a radius. So I'm going to draw in the rest of my radii because there's an infinite number of radii that I could draw in. And if I can find this one or this one, it will tell me how long that is. So key here is saying that XA, XB, and XY are all radii. And notice again, the plural for radius is 2 i's at the end. So I'm going to create a right triangle. My right triangle, let's just pull one of these guys out right here. And let's deal with that. And we have 6, 8, and our missing piece. Now, some of you might already see this, but if not, you have 6 squared plus 8 squared equals x squared. And we can work all this out. I'm going to tell you x is 10. Because this is also 2 times our 3, 4, 5 Pythagorean triple. And that saves a ton of time if we have that memorized. We don't have to go through the Pythagorean theorem, but we would get there anyway. So now that I know this piece is 10, that guy's 10, this guy is 10, and because they're all radii, xy is 10. Well, if you already know what xw is, I can simply subtract to figure out what wy is. So if we went all the way back to the beginning of the year, our geometric writing, where we did our segment addition postulate, if we really wanted to write all this out and not just write the answer and we're done, because most of you are like, the answer's 4, the answer's 4, the answer's 4, shut up already, the answer's 4. I get it. But again, we're talking about a little bit more of an enrichment, so what else do we remember from the past? Think of it as review. Our full segment is xy. It's created by taking the smaller segment xw plus the other smaller segment wy. So that's our segment addition postulate. We plug in what we know. Well, if all the radii are congruent, kind of like our transitive property, if this is 10 and that's 10 and this are equal and this are equal, they're all going to be 10. So 10 equals 6 plus wy. That's our substitution. And when we subtract, we end up with 4 equals wy, and that's our subtraction property. So you can kind of see just in this one example, I get it. 4 was fast once we figured out how to look at this and see that all of our radii, even the one that was hidden, a lot of times we concentrate on those two as separate pieces and we don't see the whole thing as a radius, but it's a radius here and a radius here. It's still going to be a radius here. Once we figured out it was 10, again, many of you are like, write down the answer 4, let's move on. But I said, let's review some. Let's go back a ways and try to look at that and see what we can remember from past chapters. So we did. We incorporated the transitive property, postulate, we substituted, and we subtracted to solve. The big idea here was drawing in our own right triangle so that we could solve and subtract. So that's all I'm going to do today. We are going to again revisit come Monday some more stuff with circles. Please pay attention that I am going to continue to post things to Google Classroom as reminders and as enrichment and everything in between. So I will talk to you again on Monday, but I will be posting everything to Google Classroom today, tomorrow, Friday, always, that kind of stuff. So I will talk to you all again soon.